After running the big cathedral port head test, I had to do the same thing for the rec port guys. So I grabbed a set of LS3 heads and we compared them to a ton of different ported versions. I even threw in 2 bonus tests. So let's get going. If you take a look at the big cylinder head test I did on the cathedral heads, if you haven't looked at that video, check it out. It's right here. But if you look at that video, you'll find I used a 408 stroker test motor. And the reason for that is I wanted to make sure we had enough test motor to take advantage of what the ported heads had to offer. And as important as that was on the cathedral port heads, it's even more important on the rec port heads. So why, you ask? Well, if you take a look at the flow rate of a factory LS3 head, it flows between 315 and 318 CFM. That's enough to support a lot of power, a lot more than any factory LS3 makes. But in our case, on our test motor, we were able to make almost 700 horsepower with the factory cylinder head. That's right, we made 691 horsepower on our test motor with a factory LS3 head. And it just goes to show you how much power there is hiding in the factory head. But it also shows you how important it is to have a test motor to take advantage of not only what the factory head has to offer, but also what the aftermarket heads have to offer. I mean, they flow even more than the factory head. So you need enough motor. So let me put this into perspective. If we run a set of 600 horsepower heads on a 500 horsepower motor, that's already enough head. If we add a set of cylinder heads that will support 700 horsepower on our 500 horsepower motor, it's not going to make much difference because they already have enough cylinder head. So we put together a combination that would take advantage of what all these ported heads had to offer. And in my opinion, what they showed, the factory head works pretty good. Let's check it out. In the introduction, I covered a little bit about why we wanted to have such a powerful test motor to utilize the cylinder heads. So now let's go over the test motor specifically. This was a 468-inch stroker. I started off with an LS6 aluminum block, and then we had things sleeved by Dart so that we could run a longer, crankshaft. Last thing you want is the pistons coming out of the bottom of the cylinder, so if the sleeves are stock length, that can become a problem. So we already knew we were going to run a lot of power with this thing, so we had Dart make some sleeves for this and press them in, do all that stuff. So we had a sleeved block, and we had a 4-1-85 bore and a 4-250 stroke crank. So it's a good combination. We also used, it's a flat top piston, so it turned out to be around 12 1/4 to 1, so we had lots of compression. Naturally, we ran a big camshaft. I just kind of went to the bottom of the page on the Comp Cams catalog, and we put in a camshaft. It was still a hydraulic roller, 624 lift with a 1.7 rocker, and that would be a 661 lift with a 1.8 rocker, which we would use on one of the sets of mast heads, I think. That was a 624 lift, 255, 271 degree duration, and 112 degree lobe separation angle. So it was a pretty healthy hydraulic roller cam, but it's a big motor. We also had a Mylodon oiling system on it, which worked really well. And then obviously we had the various cylinder heads. Now for induction system, I chose a Mast CNC ported split single plane intake with a 4500 Dominator flange on it. Again, we wanted to make sure we had enough intake to feed all this. But stick around to the end, and I can show you what happens when we put a fast intake on this compared to the single plane. So how well does a fast intake, which obviously was never designed for a 468-inch stroker motor, do compared to that big single plane, especially with this much camshaft and displacement and stuff? It's pretty interesting. On that single plane intake, I also ran a 1050 Ultra Dominator Holley carburetor. Naturally, we dialed in the air, fuel, and timing on all these combinations to make sure that they ran well. We ran, because this was 12.5 to 1, we ran this on a mixture of 91 octane and 100 pump gas and race gas mixture. So it all worked out well. So to get things started, we started off with a factory set of LS3 heads. Obviously, all of these things had valve springs on them to use with this particular camshaft. So equipped with the factory LS3 heads, this thing produced 691 horsepower, 468, and 625 foot-pounds of torque. Incidentally, if you take a look at how much power this thing makes with the factory head, this is exactly why we chose such a big combination to test these LS3 heads, and why I didn't just run a stock 6.2 liter. So if we take a look at this power output, 691 horsepower, and compare that to the airflow offered by a factory set of LS3 heads, we get 691 horsepower divided by 315 CFM. That means we're producing 2.19 horsepower per CFM, which, as we know, anytime you're over 2, you start getting into a point where you can probably get some good power gain. So let's take a look at our first set of cylinder heads. This is a set of CNC ported GM Performance Parts heads. And you can see we picked the power output on the CNC heads, jumped up to 720 horsepower. Peak torque was only up slightly to 629 foot-pounds of torque. But as you can see, we gained power from 4,300 or so all the way up to 7,000 RPM, which is as high as we ran this motor. But it's interesting to note, and we'll see this, that if we go from 691 to 720, that's not a huge gain in power. It just shows us that the factory heads, because they flow so well, we're already working pretty well, and why it was probably a good idea not to just try to test all of this on a 6.2 liter factory LS3. Let's take a look at our next set of cylinder heads. Next up on the list of LS3 heads we ran through our 468. After running those GM Performance Parts CNC heads, I wanted to find out how well a set of ported factory heads would do. So we sent a set over to the guys at Total Engine Airflow way back in the day, and they work out pretty well. Here's what happens when we ported a set of factory stock ones. That's a Total Engine Airflow. Power output jumped from 691 to 719. Peak torque was up to 631 foot-pounds. So again, gains kind of through the whole curve, but it wasn't out until here at 7,000 RPM, where we went from 682 to 720. So, substantial gains out there, but, not huge down low and stuff. Those factory LS3 heads are really just tough to beat. Let's take a look at our next set of cylinder heads. The next set of port heads came from the guys over at West Coast Cylinder Head. We use those in our cathedral port head test, and so we talked to them again. Hey, can you guys get us a set over for our LS3 head test? Yeah, no problem, man. We'll take care of you. Let's take a look and see. This is our factory LS3 head. Here are our West Coast CNC ported LS3 heads, and they did well. Picked up power everywhere. Pushed the peak power up to 726 horsepower. Peak torque was up to 630 horsepower, 630 foot-pounds. So again, these did well. But if you take a look, we're talking about 691 to 726. That's a decent gain we're showing there, but again, it just goes to show how well the factory heads do. They flow a ton. They already flow 315 CFM. So ported heads are working. Let's get to our next set. The next set of heads came from the guys at then ProComp, and now they're Speedmaster. So let's take a look at the set that they offer. I actually have two sets. One set from them, directly supplied by them. I also have a set from Dr. J, from Bryce over there, Dr. J, when he was doing that. He used their as-cast piece and then did his own program on it, and I'll show you both of those. But we'll get started with the one supplied by ProComp. So they did pick up a little bit of power, not quite as much as the rest of the guys. They produced 717 horsepower. Torque was almost identical at 625 foot-pounds. But as you can see, through most of the curve, as a matter of fact, down low, the factory heads were a little bit better. And then they picked up power from about 5,400 on up. So these are the heads supplied by the guys from Speedmaster. Now let's take a look at the set that the guys from Dr. J's did. After running the set directly from ProComp or Speedmaster, let's take a look at the set that the guys from Dr. J's tuned up back with Bryce when he was in business. So take a look. He got quite a bit better gains from this combination. He obviously spent some time making these things work. Equipped with this ported version of that ProComp head. It's 730 horsepower. Peak torque was up to 629 foot-pounds of torque. So we got good gains from, starting at about 43 or 4,400 RPM. As with most of them, the best gains and the biggest difference between the ported head and the factory head were out at 7,000 RPM, where we saw 682 versus 728. So we got some good differences out there, but obviously that casting that the Speedmaster has can work pretty well. You just got to apply yourself, and those guys from Dr. J's did a good job. Let's check out our next set of heads. Our next set of heads came from the guys over at Skagendicky Performance Center. They've been doing this a long time, and they know how to make power. They've got a good set of heads, and we tested those. And make sure to take a look at the end. Stick around to the end of the video. I'm going to give you all of the data on all of the heads, just like I did with the Cathedral Port head test. We give you all of the specs on all of the heads. We give you all the intake airflow data, all the exhaust flow data, so you can compare all of those directly to each other. It's a much easier format. Here's our factory LS3 head, and here's what happened after we replaced those with the CNC ported heads from Skagendicky. And this was one of the first instances that we ran into with this testing where we picked up power basically everywhere. Now I'd like to go back and look. I want to make sure that that this isn't a function of temperature, but I don't think that it is. We were pretty stringent about the test procedure on this thing. It's just interesting that we got power gains everywhere throughout the curve, which is nice. I mean, the Skagendicky Performance heads produced 722 horsepower. Peak torque was 635 foot-pounds of torque, so they did really well. And they even picked up a little bit of power down here at the 3,500 RPM range. So all in all, a good combination. I like getting extra power at the top, which is fairly easy with more head flow or more camshaft. But I like it even more when we get power gains throughout the whole curve. Let's take a look at our next set of heads. Since we were running a cylinder head test on an LS, and this particular one an LS3 based stuff, naturally we contacted the guys from Lingenfelter Performance, and they supplied a set of CNC ported LS3 heads. Their heads produced 714 horsepower. Peak torque checked in at 627 foot-pounds. And just good gain here in the 4,500 RPM range. And then, like the others, they picked up power through most of the rest of the curve. Kind of the same down here, down low. Pretty typical of the ported stuff. Those guys know how to make power. Let's take a look at the next set of cylinder heads. The final set of heads we ran on our ported LS3 head test came from Mast. And this one should probably get the most comments, so let me know what you guys think. These heads were the large bore LS3 heads, because we tested the small bore versions on the Cathedral Port head test. So this is the large bore Mast LS3 heads, and they had one difference from the rest of them. These things utilized factory 1.8 liter LS7 rocker. So these things had more lift than all the rest of them, and they definitely made more power. So I want to know what you guys think when you see the power results. Was this just a function of the added lift? Because the lift jumped from 624 to 661 with the 1.8 rockers. Let's take a look at our mast head. See, it was quite a bit different than the others. With the mast head, this thing produced 761 horsepower, and peak torque checked in at 645 foot-pounds, which is, pretty stout. I mean, pretty big gains. Started picking up power even down as low as 4,100 or so, but had big gains, and that's a big peak power number. So let me know what you guys think. I mean, the mast heads have always worked well. They've always made good power. If you take a look at the Cathedral Port head test, those small bore LS3 mast heads work good. And these guys know how to make power. They do it pretty well. This head worked good. As a matter of fact, it made the most power of any of these heads. But how much of it do you think was from the change in rocker ratio? Let me know what you guys think. So as promised, this is the first of our bonus tests. This isn't a LS3, cylinder head related thing, but I wanted to find out, since we had this thing on the dyno and we were using that big single plane intake with a carburetor on it, we want to find out, what happens if we run this thing fuel injected? What happens if we ran a 468-inch motor with a really big cam and lots of compression, these big cylinder heads? What if we put like a fast intake manifold on it, a fast LS3 intake manifold on it? So let's take a look. We can compare the fast intake to the big single plane mast intake, And obviously on this combination, you would think a single plane would definitely be the way to go. It's this big 4500. You know, we're running this thing all the way out to 7,000 RPM. On this Mast one, we didn't run it that high, but normally we did on the other motors. So here's what happened when we ran this thing with a fast EFI intake manifold. Now, not surprisingly, the big single plane made more peak power. It made 761, and with the fast intake, we made 731. So on the surface, seems a big win for the single plane intake manifold. 30 horsepower gain is quite a bit. But as you can see, from 5,800, 5,850, all the way down, the fast intake made more power. So I don't know where you'd want to be running your 12.25 to 1 468-inch stroker, whether it be more tuned for the top or the bottom, but it's an interesting comparison. This is all just runner length, like we always show. If you take a look at the intake manifold test, the giant LS3 intake manifold test I did, both part 1 and part 2, the EFI and the carbureted stuff, this is always the case. If you run a long runner intake on, it just makes more power down low through most of the curve than the short runner single plane stuff. And this is even more prevalent when you're not doing it on a 468-inch motor, when you're doing it on a normal displacement like a 6.2 liter or even a 7 liter. So down low here, I mean, we had a change from 618 foot-pounds, 578 to 618 foot-pounds. So it's a big change in torque production. Let me know what you guys think. Which way would you go? Would you go with the single plane on this thing, or would you go with all the extra low-speed power of the long runner kind of fast intake? Well, let me know. Here is bonus test number 2. There's got to be questions out there. Guys wondering, well, here are all the rec port heads, all the LS3 ported stuff versus the factory one. But my question is, on a big motor like this, a 468-inch motor, does a cathedral port head work? I mean, especially a big one. I mean, if you take a look back at the cathedral port head test, I ran 245 airflow research heads on it, which are probably oversized for that application. I mean, it was on a 408, but even on that 245 would be much better on a much bigger bore and stuff. So, hey, let's throw those 245s on this test motor and find out how well really good cathedral port heads work. So we did exactly that. Let me know what you guys think. What do you guys think before I put it up there? What's going to happen? Are they going to work? Are they going to be terrible? Are they going to be good? Here's what happened when we ran the 245 heads. Now, we ran the 245 heads also with a fast intake, just like these Mast heads with the fast intake. So here's the comparison. Well, and I think maybe not surprisingly, the Mast heads were the best rec port heads that we tested, so they did very well. The 245 airflow research heads did very well. They made 711 horsepower, and the Mast heads made 731. So we got a difference of about 20 horsepower. And as we might expect, the cathedral port heads were better down low, down below 4,000, which is typically what we see on any kind of rec port versus cathedral port head test. That's usually the case. Usually the cathedral port heads are better down there. But it just goes to show you that even, we made over 700 horsepower, 711 horsepower with the airflow research heads. So they did well on the cathedral port side with the fast intake manifold. But they weren't quite as good as the Mast LS3 heads with a fast intake manifold. So there's your comparison. Let's get to our conclusion. Before we get to our conclusion, let's take a look at all the specs and airflow data offered by all our cylinder heads. Here are the specs for all the LS3 cylinder heads we tested. Here's the intake airflow data for all the LS3 cylinder heads we tested. Here's the exhaust flow for all the LS3 cylinder heads we tested. Okay guys, what did we learn from porting all of these LS3 heads and testing it on our big stroker motor? Well, here's what I learned. The factory LS3 head is really good. I mean, we made almost 700 horsepower with the factory head. And it tells me there's a lot of potential left in that factory head, and we need a lot of test motor to take advantage of what ported LS3 heads have to offer. In fact, and I know I'm going to make a lot of rec port guys mad here, if I had a 6.2 liter LS3 or even a 6 liter LY6, and I had to upgrade the heads personally, I probably wouldn't because it already has a good set of heads. I would just concentrate on the camshaft. But if I wanted to upgrade the heads,
I would probably put a set of ported cathedral port heads and a fast intake manifold on it. I did a test recently where we upgraded the factory LY6 heads and put TrickFlow 225 CNC ported heads on and a fast intake. We picked up a ton of power on that combination. Now we picked up a ton of power down low and a ton of power up top. It basically was better everywhere. So on that smaller displacement, 6 liter or 6.2 liter, I definitely would go with probably cathedral port heads if I upgraded it at all. Now for me, I probably wouldn't. The factory heads are already pretty good. I'd concentrate on the camshaft, then add boost. Armature holder, guys, thanks for watching. Make sure to like, share, subscribe, ring the bell. I'll keep testing.